Hello, welcome everyone. I hope you all have been having a great Thursday. It's been a pretty busy day for me, and I'm here in South Florida, and now it is pouring, which is typical of South Florida weather. But it's been an awesome day, and now I'm excited to bring to you all another LeetCode Beginners Guide Explore video, where today we're going to go over the richest customer wealth. So make sure you head over to question 1672, and let's go ahead and get started. So, richest customer wealth, it says, you're given an m by n integer grid accounts, where accounts ij is the amount of money the ith customer has in the jth bank. Return the wealth that the richest customer has. A customer's wealth is the amount of money they have in all their bank accounts. The richest customer is the customer that has the maximum wealth. So if we take this array, for example, each one of these sub-arrays are the individual monies that this person has in their bank account. And if we add all these together, 1 plus 2 is 3, 3 plus 3 is 6. Similar here, they both have the same one, so we return 6. But let's do this one, which is a little bit of a better example. If we add all the intermediary values together, we get 6, 10, and 8. Out of all of these, 10 is the largest one, so we return 10. Now, there's at least 3 different ways that I can think about doing this question, so let's go ahead and write those down. So the first one would be the classic, keep track of the maximum. The second one is keep track of the maximum, and I think, let me see, that's just gonna give us the max. So maybe, is that a good way to do it? I guess I was trying to make number 2 like a shorthand for number 1, but maybe they're both gonna be the same. So if anything, let's make number 2 the second one, which is keep or use fancy higher order functions like reduce. And let's see how we can think about that one. I think that's gonna be a lot of fun. So what do we do? Let's see. Let's think about this first one. Keep track of the maximum. So we have all these different ones here. Let's see how we can do that. So for this one, I want to use a for of loop in JavaScript. I think it's going to handle this sort of question very nicely. Let's say here we'll say max wealth is equal to 0. We can say for const account of accounts, right? We'll say let current wealth equals 0. And then we can say for const money of account, here we can say money, or rather current wealth plus or equals money, and at the end we can say max wealth equals to math.max of max wealth or current wealth. And finally at the end we return max wealth. So if we go through this question again, let's start here on this one. Let's say for const account of accounts, so this represents the first account, current wealth is 0. And then we do for const money of accounts. So money represents each of these individual monies inside of the account. Current wealth plus or equals money. So plus 1 plus 5, that's 6. Then we say max wealth is equal to math.max of the current max wealth, which is 0, or current wealth, so that's 6. We set that to max wealth. Second time we come around, we do the same thing. 7 plus 3, that's 10. So now we're going to be comparing 6 and 10. 10 wins. We come back again, 3 plus 5 is 8, so we will be comparing 10 and 8, 10 wins, so we return 10. So let's go ahead and remove all this. Let's run this for all our test cases. We have 6, 10, and 17. Let's go ahead and submit that. 94.42, a very nice number that we love to see. Very nice, close to 100. That sounds like a great way to start off on this question. So that's how to do it this way. Now, there's sort of a more advanced, maybe nicer way of doing things, although I would probably say that doing it like this is the most readable way of doing it. So we can use something in JavaScript called reduce, where what we're doing is we essentially just reduce each of the different, we reduce all these intermediary arrays into a single array. But if you really think about it, we can also reduce the outer array into a single array. So let's see if we can do this in a two-step process, right? What is it that we want to do in here? We can reduce the account, and that's essentially going to give us the max wealth, right? So instead of doing any of this, really what we can do is we can say, let's see, we can say math.max of max wealth, or the current wealth, is what? The current wealth, again, represents the sum of the individual values inside of this array. So to get that, we can do account.reduce, where we have an accumulator and a value, and we just simply return accumulator plus value. And our initial value will be 0, because at that exact moment that we started, we don't have any money, right? So what account reduce is going to do is it's going to take the accumulator, which is going to be set to this initial value, and it's going to add the current value to our accumulator every single time. So it's going to do 1 plus 5, and then we'll compare that with our max wealth and keep going, and we'll do that for all the other accounts. So let's see what this looks like. We have a 6, a 10, and a 17. Let's run this. All right, so 35.55. Okay, now let's see if we can go even a step further and now reduce this entire thing. So what I want to do is I'm going to keep this as a reference. And now let's try and do this. We're going to return accounts dot reduce. And what is it that I want to return here? My accumulator is still going to be 0, but my value, right? So in this case, when I was doing a reduce on a single account, my value represented a single amount of money, right? It was just a 1 or 5 or 7 or 3. But here, my accumulator, maybe my accumulator here should be my max wealth. That way I can sort of read these values a little bit easier. Maybe this will be max wealth, and my value here will be an account, right? So what are we going to do when we return this? Inside of here, what we want to do is we want to return, let's see, if we get the math.max, can we return, let's think about this. How do we reduce it to a single value? I guess we can calculate the max, and we can just return either of them. So let's say we calculate it once and we get our current max wealth. And for the second time that we do it, what is it that we want to do? We only want to return if it's greater than the previous one that we've set, and that's going to be max wealth anyway. So maybe, let's see, maybe in here I can say return math.max of max wealth, or still reduce this. And now let's see what that gives us. We really just took what we already had here, and we're also returning it inside of this other reduce. So let's do this. Let's remove all these, so we're just left with that single return statement down here. We have nan and nan, and I think that's because I did not give this a starting value. So let's make sure we do that. Six, 10, and 17. Let's submit this. 13.86. So pretty cool problem. I really like the way this problem is formulated. It's about the same difficulty as the one that we saw yesterday, the running sum of a 1D array. The cool thing is we went to 3 different ways of solving it. The first one is we just did the classic keeping track of the maximum wealth, updating it as we went along, which frankly I think is the best in terms of readability, because all these are still going to add up to be the same time and space complexity. And then we did something similar where we sort of beefed it up, and we took advantage of some of these higher order functions like reduce in JavaScript, and I know reduce is available in other languages as well. We took advantage of these higher order functions, and we sort of made it a little bit more, how do I say, functional perhaps. So we did a nested reduce here, and we were able to still get the same thing. So really I'm just trying to educate you all, show you how you can maybe use some of these methods to come up with some cool looking functions like this. So if we go over the space complexity, if we think about it, we're always going to have, like if we look at this first example, we have 2 separate accounts, but each account has its own amount of money, right? So because of that, you can really say the time complexity is, let's say, A times M, where A is the amount of accounts and M is the amount of money per each account. That will be the time complexity, and the space complexity here is going to be constant, because for all of these ones that we're using, we're never really having to create any extra space to keep track of any one of these, any one of the max wealth. Now, a question I actually have for myself, and I think it would be cool for us to learn about, is for account reduce, are we having to, are we creating, I mean, we're still going through every single element in the array and we're just returning a single value. We're not creating a new array. I was thinking of almost something like map, where we return a new array, and that might mean that we're also creating a new array, which might impact our space complexity. But because here we're only returning a single value, I believe the space complexity will still be constant. So I'm still going to say that the time is going to be A times M, where A is the amount of accounts, M is the time of money, and the space is constant because we only need to keep track of the max wealth, which does not really change depending on the size of our input. So I really hope this was helpful for everyone. I'm really happy that I've been doing this. I know that this was something that people have wanted for a while, so it's pretty cool to come back and now be doing a more structured series of videos, especially surrounding Explore cards, which in and of themselves already make it for a very structured experience. So stick around. I'll be doing another video soon, and the next one we'll be tackling is FizzBuzz. So thank you all so much. Hope you all have enjoyed your Thursday, and I will see you all next time for another video in the Explore series. Happy coding.